So imagine trying to stretch your entire 4K display setup across like 20 football fields.
Oh, good luck with that.
Right. If you tried doing that with standard cables, you wouldn't get a crisp picture. You'd get digital snow or horrible lag or just a completely blank screen.
Yeah, standard copper wire is definitely not built for that kind of distance.
Exactly. Okay, let's unpack this. Our mission today is a deep dive into a really dense technical spec sheet we have from HDTVSupply. It's for an AV receiver called the Smart-AVI HFX-UX-PRO-RX-S.
It is a total alphabet soup of a name, I know.
It really is. But hidden inside all those letters is a massive leap in how we transmit heavy, uncompressed data over ridiculously long distances.
And it really comes down to fighting physics. Because when you push high-resolution video over standard cables, the data is traveling as electricity. And, electricity runs into physical resistance.
Right, so the longer the copper wire, the more resistance.
Exactly. Plus heat and electromagnetic interference from the environment. You have to deal with all of it.
Sending uncompressed 4K video at 60 frames per second over long copper cables is it's like trying to blast a fire hose of water through a tiny plastic drinking straw.
That is a perfect analogy.
And by the end of it, the echoes and the noise just turn the whole thing into gibberish.
But wait, doesn't something like this normally require a massive, bulky bundle of specialized cables?
It used to, yeah. Traditional extenders demand these really specialized dual fiber cables just to handle the bandwidth. But what's fascinating here is that this SmartAVI unit achieves transmission using just a single fiber cable connection.
Wait, really? Just one?
Just one. It translates the data into light, shoots it down a glass thread, and it sidesteps all that electrical resistance entirely. It goes up to 2 kilometers, about 1.24 miles on single-mode fiber.
Okay, let me push back on that a little.
Okay.
Because looking at these specs, it says it reaches 1.24 miles on single-mode fiber, but only 1,000 feet on multi-mode fiber. Even light scatters eventually, right? Why the massive drop-off? That is a great catch. And it's all about how the light actually travels. Think of multi-mode fiber like a slightly wider hallway.
Okay.
The light bounces off the walls as it travels. Over short distances, that's fine. But over a long distance, those bounces cause the light signals to scatter and blur.
Ah, I see. So the signal degrades.
Right. Single-mode fiber, on the other hand, has a microscopic core. It forces a laser to travel in one perfectly straight line without bouncing, which is how it hits that incredible 1.24-mile distance.
Wow. Okay, but here's where it gets really interesting. We've managed to blast our video a mile down the road, but a screen is pretty useless if you can't actually interact with it,
Yeah, you need control.
Right. And this receiver also handles transparent USB 2.0, keyboard, mouse, and bidirectional stereo audio. It also mentions something called ED emulation.
Ah, yes, ED emulation is huge here.
Because normally a computer requires a digital handshake from a monitor, right? Like if it doesn't get it, the computer panics and just refuses to send video. So this emulation basically fakes that handshake constantly.
Spot on. The receiver is constantly telling the distant computer, don't worry, the monitor is right here, keep sending the signal.
Oh, that makes so much sense.
Yeah, that mechanism is the why behind this entire device. It essentially teleports the workstation. Think about, say, running a sprawling university campus or a massive sports bar.
Right, you'd want the actual computer hardware safely tucked away.
Exactly.
Ugh.
In a secure, climate-controlled server room where it's safe from spilled drinks or overheating.
But the person actually sitting at the desk or managing the displays, they need to feel like that machine is right at their fingertips.
Precisely. And because of that digital handshake, plus the speed of light through the fiber, the user experiences zero difference from sitting right next to the physical computer.
That's wild. It works across Windows, Mac, Linux.
Full compatibility. The audio goes both ways, and mouse clicks register instantly.
So what does this all mean? Well, for you, our listener, we're talking about a piece of equipment that costs around $764, and it takes tech that used to require massive corporate infrastructure and makes it accessible via a single fiber line.
Yeah, it's incredible. If we connect this to the bigger picture, it fundamentally eliminates the barrier of physical distance in high-end AV environments.
You're completely decoupling the user interface from the processing hardware.
Exactly. It gives systems architects total freedom to put the brains of an operation wherever they want, without punishing the end user with lag.
Which leaves you with a pretty wild thought to mull over. If a single thread of fiber can perfectly carry a 4K computing setup, Your keyboard, your mouse, and your audio across 20 football fields. Are we rapidly approaching an era where having a physical computer hardware tower in your home or office is entirely obsolete?
It really makes you wonder.
Right. Why deal with the noise, the heat, and the clutter right next to your desk when your entire digital world could just be piped in from a mile away through a single invisible strand of glass?